This conference will now be recorded.
Good evening, everyone. I am Rashmi Jain. On behalf of Agriculture, meeting. Please take a second to review the online meeting posted in the chat window. I now request the moderator, Mr. Lakshmipati, to introduce the speaker and start the meeting. Thank you.
Thank you, Ms. Rajini. Good evening, everyone. I am Lakshmipati and I'll be moderating this meeting. Agricultureinformation.com likes to welcome to this meeting Mr. Sai Krishna, junior breeder at Mangal Murthi Seeds, East Godavari district, Andhra Pradesh. Mr. Sai Krishna will be speaking on the topic speed breeding, a promising approach to crop breeding. I now request the speaker to begin. You please put on your mic, Mr. Sai Krishna. Your mic is off.
Yeah, good evening, sir.
Good evening. Go ahead.
Good evening to one and all who are present in this presentation meeting. So thank you for a brief introduction about myself. And here I'm Sai Krishna, working as a junior breeder in Mangal Murthi Seeds. So let us start our presentation, right? So the topic is about speed breeding, promising approach to crop breeding. So let's see what are the agenda we have in the speed breeding. So I'm about to discuss about how to overcome the crisis of food quality and shortage, growing population in the near future. And speed breeding is the key to achieve resilience in agriculture. And difference between the conventional and speed breeding techniques are what we are using currently, and how the future can be better with speed breeding, and what are the opportunities of speed breeding techniques, and what are the challenges of speed breeding. So before starting the presentation, let me show you a little introduction about what is speed breeding. So we all know by 2050, it is expected that the world population will grow to nearly 9 billion, and this increase over need for the food by more than 100%. So currently, it is 1 out of 8 people are struggling with hunger every day. Even more so, roughly 1 billion people currently are lack in access of sufficient quality of affordable and nutritious food. Increase in urbanization and rapid growth of human population, the adverse environmental conditions, they raise a significant concern for the global food security. So it is concluded that 60 to 80% increase in production is to be done in the same cultivated land to be handle the food crisis. So the land we are using currently for the agriculture can't be grow. So we have to increase the yield or the productivity of the land we are using currently. And this leads to the rapid demand in the high yielding varieties to be developed in the near future. Breeding new and high performing cultivars with the market preferred traits takes more than 10 years to following the conventional breeding techniques. So, what are the procedures that we have to go through before developing a new variety? So the first one will be the selection of the desired parents. So we have to select a desirable parents to make a specific crosses based on the complementary traits we have about to choose. And the second step will be the making successful crosses to develop the progenies. And after making the crosses, we have to select from the progenies based on the traits we have targeted. And the selection of the best progenies that perform well in multi-location trial. So we have to go through different multi-location trials so that we can know which variety is suitable for a specific location, and identify the stable and best cultivars. After we are choosing this best cultivars from the our list. So we have to make the cultivar registration and seed multiplication and distribution to growers. So all these procedures will be gone through for about 12 to 14 years for a variety to release in the market. So the breeding process requires significant amount of time, space, resources, and investment in the initial development stage. Why speed breeding? So speed breeding is a new and existing approach to breeding, originally inspired by the U.S. National Astronauts and the Space Administration (NASA), that promises to develop new crop varieties faster, offering hope for the food security in the continent. We are currently experiencing that our humans are exploring Moon and Mars. So this technique the NASA has developed, they are planning to uh, grow different crops in the other planets uh, other than Earth. So this technique is basically developed by the NASA for that purpose. But it is a suite of techniques that involves the manipulation of environmental conditions under which crop genotypes are grown, aiming to accelerate flowering and seed set to advance to the next breeding generation as quickly as possible. And this technique involves growing plants under conditions light. So we will generally the plant gets about 10 to 12 hours of sunlight, and here in the speed breeding we provide artificial sunlight, artificial light for about 20 to 22 hours. This allows the plants to photosynthesize for longer, resulting in the faster growth. Professor Lee Hackey from University of Queensland, Australia, has successfully adapted this method in wheat, barley, mung bean, and chickpea. Speed breeding has the potential to reduce the time required for cultivar development, release, and commercialization. So, in the common cereal and legume crops, the crop cycle is typically 3 to 6 months per crop. So, per a year, it is only about 2 to 3 generations we will go through for any cereal or legume crops. But by following the speed breeding technique, we can get the results of 3 to 9 generations in a single year compared to the 1 to 2 generations per year achieved with the conventional breeding approach. So speed breeding can be used to achieve up to 6 generations per year for spring wheat, uh, durum wheat, barley, chickpea, and pea, and 4 generations for canola instead of 2 to 3 under the normal glasshouse conditions. So let us see what are the difference between conventional and speed breeding. So in conventional breeding, it is a high timely consuming. Right, it will take nearly 10 to 14 years for the variety to go commercial by following the conventional breeding. But in the speed breeding technique, it is very less time consuming and give you quick results. And we can only get 1 to 2 generations of a crop per year in conventional breeding. But whereas in the speed breeding, we can get 6 to 9 generations per year. And large area and manpower is required for the conventional breeding. So as we are uh, taking a long time, the manpower with the skilled manpower are required for a longer duration. Whereas in speed breeding, areas required is comparatively very less as we grow crops in a controlled location environment. So we required very little uh, land, and only few skilled labor are sufficient to do this program. It takes about 10 to 14 years to commercialize and release, but with a rapid to develop through speed breeding. So here I have listed some more than 100%, like in amaranthus, the sixth generation we can grow in 1 year. And like a barley we grow hardly 2 seasons per year, and here we can grow 9 seasons for a single year. Canola, four four generations. Chickpea, 7 generations. Rice we hardly grow 2 seasons or three generations, but by following the speed breeding method we can get 4 generations per year. Likewise, so the speed breeding technique will fasten the growth of plant and reduce the time duration taken by the developing of the new variety. So what are the opportunities or what are the things that are needed uh, for a speed breeding practice to project to be done? So rapid development of homozygous lines for accelerated breeding. So we in speed breeding we follow these steps that make the plant to grow rapidly and give results very quickly. So the first and basic thing we need is the manipulation of photoperiod. Photoperiod is the nothing but the length of daily exposure of plants, length, length of sunlight that is exposed to plants daily. So it is important to determine the optimum light quality, intensity, and photoperiod that triggers flowering initial in various crops. Uh, like in some crops, it is like without sunlight, the flowering won't emerge, and without sunlight, the uh, seed setting won't happen. So in that case, many of the crops, so the photo period, when we are increasing the photo period of the plant will grow very rapidly and gives the yield very quickly. So here we use photosynthetic active radiations that comes to we use generally LED lights for producing the photosynthetic active radiations with the range of 400 to 700 nanometers and the intensity of 360 to 650 micromoles. When this measurement of wavelength and range has been successfully used in many crops like wheat, barley, chickpea, pea, and canola to facilitate the speed breeding. And Dubchowski is a scientist who found that the photo period of 22 hours light and 2 hours dark under PAR photosynthetic active radiations of 150 to 190 micrometers reduce the total number of days to flowering by half. So it is like uh, for any crop, if it takes 50 to 60 days for initiation or flowering, so it is only we get flowering by 30 to 25 days when we increase the photo period of a crop. And the second goes to the regulation of the temperature. So adjustment of soil and air temperature affect germination and growth responses. We see in winter climate, the germination won't happen in many crops because the germination to happen, there is a specific amount of temperature that is needed to trigger the germination in many crops. So this temperature regulation is done in the speed breeding program so that the germination and also the growth response will be rapid. That helps in the faster growth of plant. And the temperature required for germination for most crops are between 12 to 30 degrees centigrade. So whereas the optimum temperature for growth, flowering and seed set varies from 25 to 30 degrees centigrade. So with the changing in the rapid change in this in our climate conditions may affect the crop duration to go further. So in the speed breeding, we almost uh, optimize the environment we provide so that the plant will have exact amount of temperature and light, nutrients, so that the plant will get all the requirements for the faster growth. So temperature regulations allowed the germination to immature seeds freshly planted into pots, which allowed for the production of 7 generations per year. with the regulation of temperature. And here comes the third step for the regulation of soil moisture. Soil moisture stresses can cause significant changes in plant growth and developmental process affecting plant height, days to flowering, and seed set and maturity. Sometimes soil moisture, when we have a uh, drought stress, it is most commonly applied a technique for crops such as wheat, barley, and pearl millets. Like when we have drought stress condition, the plants will thought it is very urgent for them to mature faster to produce a seed. So this triggers the plants to grow rapidly and give the yield faster. So it is observed in wheat, barley, and pearl millet. And in wheat and barley, irrigation when plants show wilt symptoms. Wilt is nothing but when excess water or is conditions are produced, the bacterial will start killing the leaves, and the wilt symptoms will grow rapidly. So irrigation when given with the wilt symptoms, this helps the wheat and barley to promote plant growth and develop. When the plant growing is rapid, so the disease resistance will also develop very quickly. So this counter strike the wilt growth and helps the plant to grow better. In contrast, in sorghum, drought stress delayed flowering up to 9 days in cultivars Siganol. So we have to be very particular about the cultivars we are using in the speed breeding program. Some cultivars will show positive response for the conditions we are giving for the growth, and some varieties will not respond for the conditions, artificial conditions. So we have to be very specific while selecting the cultivars in this program. Next, come to the point: the density of the plant populations. High density planting entails growing at higher plant densities than the density required to produce maximum yield. When the density is increased, uh, so results in the tall plants due to the light competition. So all the plants will be uh, trying to be reaching the sunlight so that they can absorb more sunlight and leading to the rapid transition from the vegetative to the productive growth stages. So this when we are giving a high density population in plants, so they um, grow faster with the struggling for existence. So they think we have to grow faster for getting all the nutrients to absorb all the nutrients and all. So this helps the high density of population will help the plants to grow much faster and rapid. This approach is successfully induced early flowering and maturity and increasing the number of generation cycles per year. In rice, up to 4 generations per year were achieved using a high density planting of 400 plants per meter square. So generally, while we are growing in a uh, field, we follow specific uh, spacing for the plants to observe the all the nutrients in sunlight and water, so there won't be any stress for the nutrients in between plants. But unlike in the traditional way, here in the speed breeding, we follow the dense population, particularly in the rice. So when we are following this dense population technique, so the plants will be struggling for all the nutrients, and we of course give enough conditions for all the plants to grow equally. So this technique will help the plants to grow very rapidly. And modifying the carbon dioxide levels. Increased level of carbon dioxide may enhance rapid plant growth and the speed of the transition for the vegetative to the reproductive stages in some plants. So, in contrast, increased carbon dioxide will reduce days to flowering in soybean, rice, and pigeon pea and cowpea. So, different plants will show different respond differently with the conditions, artificial conditions we are providing. So, we have to be very particular with the crop we are selecting and the conditions we have to be listed prior before selecting any crop. So use of plant nutrition, hormones, and organ tissue culture. Plant nutrition and hormones have been used to accelerate growth and to induce flowering and seed set and germination of immature seed in vitro. Combining auxins, plant hormones are nothing but auxin, cytosine. Uh, these induce a rooting or a stem growth in plants when we are growing them in vitro. So artificial plant nutrients and hormones are very important for the plants to be supplied for their rapid growth. And combined auxins and cytosine hormones in the form of chloroprimidol and indole 3 acetic acid and gelatin promotes in vitro flowering at 100% and seed set in faba bean. Uh, indole 3 acetic acid, we generally use these um, hormones even in our field crops to induce the female flowering in cucurbits, and this helps the uh, plants to produce more flowers and grow rapidly. So this approach allows up to 8 generations per year in a faba bean. So it is observed by Mobini et al. In 2015. So what are the challenges we basically face in a speed breeding? So it is like a new technique uh, in the world. So a lot of scientists are working very hard to make this technique very usable for uh, throughout the and developed and underdeveloped countries also. So a lack of trained plant breeders and breeding technicians are challenging this speed breeding process. So a lot of tech knowledge and skill is to be given for the plant breeders and also for the technicians to make this process successful. And inadequate infrastructure and high investment are the second drawback for speed breeding, as a lot of equipments are to be uh, needed for a successful speed breeding program, and unreliable water and electricity supplies. So basically, we are providing a continuous uh, photo radiations. So a 24 by 7 electricity supplement is necessary for this process, which uh, increase the cost of production, uh, electricity consumption. But this won't be problem where unreliable, like when solar electric generation places, this won't be a big problem. And here is what I'm concluding with the speed breeding. The use of speed breeding can accelerate the development of high performing cultivars with market preferred traits by reducing the amount of time we are producing a new variety in less than 5 years, and this is a great achievement for breeders, and space and resources invested in the selection and genetic advancement of superior crop varieties is also reduced by using the speed breeding process. The technique allows plant breeders to develop improved crop varieties more rapidly, and the selection process will also be very quick. Basically, we have to be do more phenotypical selection in the conventional breeding program. So when we are doing it, this entire process in vitro, so we have to go through very little population. So the selection process will be very quick, and the delivery of new variety will also be very rapid. However, the adoption of speed breeding in many countries, developing countries, especially in public plant breeding programs, is limited by the lack of trained plant breeders in plant breeding. So this technique is successfully followed in uh, more most of the European countries and Australia. Currently, Africa is also for the speed breeding program. So this is some pictures of them reporting you. where the LED artificial light is given through LED lights, and the plants are grown in the controlled environment. This is the end of my slide.
Thank you, Mr. Sai Krishna, for a good presentation and talk. I now request the participants to ask their questions. We'll also be posting the speaker's contact details in the chat window. Okay, participants, any questions, please? Any questions, please? The Pamadi and others, do you have any questions?
Yes. Thank you, sir. Thank you. Hello, Mr. Sai Krishna. It's a very nice presentation. So, given the what is the problem in this one speed of why we need a speed of breeding? They're all in the laboratory level, so it has to be taken to the field, isn't it? So, like say we have rice growing 130 days time, that should to be shortened. So, whether this has been put to the government to make a policy decision to enhance the plant breeders appointment to make more fund for research in this line, like that.
Sir, I didn't actually get your question.
See, you tell all about a scientific basis done in a research station, okay? See, this has to be applied to the field. It has to be taken to the field. You select tissue culture. Your last point you did is tissue culture. That is happening in the field now.
Yes, sir. Yes, sir.
Like banana, cashew, and then we can have lakhs of plant immediately to plant in the field, not to have normal things, you know. So you said we need more people to feed. We need speed breeding. We need to grow quickly the required food. So this is the problem we're going to face in 10 to 15 days time, isn't it? So this has to be put to the government to make a good policy decision to bring the plant breeders to the field and make it quick while they to study the things, you know. That's what whether it, you what you present is like scientific paper. It's all in the laboratory.
Exactly, sir. The government has to take chances to help the plant breeders to achieve new techniques to approach, and when they can give successful training for a lot of eager plant breeders. So this technique will be get commercially utilized in India. So the new varieties that can be developed in lesser time will be more helpful for producing food for a lot of people without any crisis.
Say, well, I will tell one example. Tell me whether it can be applied. You know, because I am from a rice growing area in Tamil Nadu, Delta area.
Yes, sir.
Due to rain, you know, the people, a lot of youngsters, educated people come to the field now, and they innovate their own method of having the nursery. You know, instead of having a traditional nursery on the field, you know, up to 5 to 10 cents, they grow in a tray, they grow in a open space in their house, like that, to have the without affecting the climate, to get in right time for planting. Okay, so you said you showed one light slide. So usually the nursery plant needs 21 days for rice from
Yes,
seed
sir.
to seedling. Okay, so you showed on slide now. We are using LED
Yeah, sir.
hasten the growth, vegetative growth. So can I have a like that? Can I have the same for the nursery of a rice plant? Will it work to shorten the period from say we can 12 days, 30 days I can plant in the field, which will grow like 21 days nursery seedling.
Yes, sir. Definitely. When coming to this speed breeding technique, we 24 in the 24 hours we produce light for 20 to 22 hours for a plant. So for any variety, any plant, a rice plant to grow, it takes 100 to 120 or 140 days for a maturation, right? So when we are increasing the photo period, when we are providing more sunlight, so the plant grows rapidly. Then the entire life cycle of the plant will only be complete in 60 to 70 days, hardly.
Okay.
It takes a nursery for sowing to seedling to produce, it takes 20 to 25 days for plants in rice. So,
Yeah,
uh,
that type of things we want to try it. So this has to be taken to the field, you know. So a lot of people don't do it. So because we are using traditional variety of rice that takes normally 135 days to 145 days time. So it's long
yeah,
period for to grow
a long
rice, you know,
duration.
for the. So we can shorten by this 5 to 10 days every season, every year. So after 5 years, maybe we can compare with this hybrid variety of rice which has 90 to 110 days time.
Yes, sir. Actually, for the commercial utilization, this process
Hmm.
won't be very successful, as a lot of acreage we use for producing, and this technique is confined to a specific uh, small amount of plants. So for commercial purpose, it won't be helpful. Exactly, we can use lights and LEDs to faster the growth, and even in the night times also, if we provide a sun light, and we have to be very particular with the amount of intensity of light we are producing to plant. Okay, and
Okay.
different crops and stages of crops, we need a different amount of wavelength of sunlight or light. So artificially, when we
Okay.
are providing,
Thanks.
we have to be particular about the wavelength of light, and we can faster the growth of the plant by providing light
Okay.
artificially.
Say one more question, sir. You showed in the reason and one of the causes to have the speed breeding, carbon dioxide,
Yes, sir.
isn't it? How it how that tell me the what is the ingredient how it enhances the growth carbon dioxide how to apply in the field because the varieties is in the wet condition it's mostly I think it's we add farmer manure in organic farming it actually generates methane so this can be converted into carbon dioxide to enhance the growth.
Uh, so this approach actually, when we are providing, we only not provide artificial light for the plants to grow. We also provide the amount of moisture, nutrients, and everything that the plant requires for the rapid growth. Uh, Everything will be in a artificial manner, but whatever the plants required for entire generation, that is provided artificially in adequate quantity.
Hmm.
So uh,
Okay.
the plants commercially won't be can't be produced by using this technique, but it helps plant breeders to select the plants very quickly. So actually, for a plant breeding selection, only takes about 7 to 8 generations. So it is about 3 to 4 years
Hmm.
for a plant breeder to select a uh, pure land plant, pure land varieties. Okay, by following this
No, no,
technique,
sir.
we get the six to
Sir,
seven
sorry, sir.
generations.
I am not asking about that. I understand all these things. I say I want to know. You said one of the reason have the speed breeding carbon dioxide. No slide. One of the slide last point is short. Okay, how it enhances the growth. I want to know the scientific base.
Yes, exactly. So the plants generate food by taking sunlight. So it is a
Okay,
photosynthesis process of the plant. So it
it needs
needs
carbon dioxide.
light for the
Carbon dioxide.
photosynthesis to occur. So we are artificially providing this amount of light that a plant requires to produce the photosynthesis. And uh, so the plants generally grow only when the sunlight is provided. Okay, in the night and the plants growth won't take place. The only
Okay.
reproductive stages will grow during the night, and the daytime the
Uh,
plant growth, vegetative growth will be taking place. So when we are increasing the photo period of the plant, like when we are artificially providing sunlight and the nutrients all requirement for the plant, so the photosynthesis will be continuously occurring in the plants. This helps the plants to grow very quickly.
okay. Thank you. Thank you, sir.
Thank you. Thank you, Mr. Madhi, for asking that question. And I think we have come to the end of the session. I'd like to thank the speaker, Mr. Sai Krishna, on behalf of Agriculture Information for taking his time to speak with us. I now request the organizer of the meeting, Ms. Rajini Jain, to please close the meeting. Thank you.
Thank you so much, sir, for
Thank you,
taking
Mr. Lakshmipati. Thank you, Mr. Lakshmipati. I'd like to thank the speaker, Mr. Sai Krishna, for taking the time to talk with us. I also like to thank all the participants for their time. The meeting will now be closed.
Thank you, sir, for having me.
You're welcome, Mr. Sai.